Hey Chemistry, Mrs. KJ here, going over 1.18, Review the Metric System. In this lesson, you will review concepts presented in the lessons Metric System, Base Units, and Metric System, Derived Units. Begin by reviewing the key concepts and mastery maps online. You can also view the key concepts and mastery maps offline in the student guide. Then review the model problems and complete the problem set offline. And I'm actually going to take notes on this review. I know usually I don't because everything is covered in the previous lesson. In this case, we're going to go over some stuff that has not been gone over before and will be on the quiz. All right, so lesson 18, review metric system. I like this sign. Look how it says think metric to remind you that you should be looking at kilometers instead of miles per hour. Okay, so they have this probably in Canada. And so if the maximum is 50 kilometers per hour, you can only go 30 miles per hour. If you're going 50 miles per hour, you'll probably have your driver's license revoked. Review concepts presented in the lessons, metric system base units, and metric system derived units. Most of the world uses the SI, which is based on the metric system. The metric system has 7 base units and many derived units, which are made from various combinations of base units. The metric system is based on powers of 10, so converting from one unit to another is simply a matter of multiplying or dividing by various conversion factors or by moving the decimal place. Derived units are used to solve problems in numerous chemistry topics. Goals, make sure you know the previous stuff as well as some new stuff. All right, so let's review what you should already know, key concepts in metric system base units. The Système International des Units, or SI, has 7 SI base units. So close your eyes. Meter is abbreviated M and measures length. Kilogram is abbreviated kg and measures mass. Kelvin is abbreviated K and measures temperature. Second is abbreviated S and measures time. Mole is abbreviated MOL and measures basically how much stuff you have. Candela is abbreviated CD and measures light intensity, and ampere is abbreviated capital A and measures current, so with electricity. Again, we're not going to use these two a lot, but they could pop up on the quiz, and you do need to know that they are 2 of the 7 base units. Now, I can understand where people get confused sometimes because usually we call liters a base unit, and we do when we do the stair-step thing, but technically liters is derived because in order to find volume, you take length times width times height. So just so you know, on the quizzes, liters is not a base unit, although when we convert from one metric to the other, we consider it a base unit. I know it's tricky, just wanted to let you know so you didn't get it wrong. SI derived units are combinations of the base units. Base units can be subdivided or multiplied by factors of 10. So you can go from centi to milli or centi to meters. Prefixes indicate the multiplication factors. So common prefixes include kilo, which means 1,000, centi, which means 100th, milli, which means 1,000th, micro, and nano, which are even smaller and even smaller. Temperature is measured in degrees Celsius or kelvins, capital K. Absolute zero is 0 degrees Kelvin or negative 273 degrees Celsius is the temperature at which all molecular motion stops. Absolute zero is the only time atoms stop moving. So even in a solid, they're vibrating a little bit, but they're still moving. You have to get to absolute zero, which is the coldest possible, in order to have molecular motion really stop. So metric base units, again, they go through them, and they combine to form derived units. And yes, you can also combine derived units to make other derived units. Key concepts in metric system derived units. The Système International des Units, or SI, has SI base units that are combined to make SI derived units. Some derived units have specific names, while others do not. Metric derived units are used in many areas of chemistry. They include the liter, which measures volume, grams per centimeter cubed, which measures density, the Newton, which they get from doing kg times meters per second squared, which measures force, the Pascal, PA, which they get from kilograms divided by the quantity meters per second squared, which measures pressure, the joule, capital J, which measures energy, and the volt, which is derived from kilograms times meters squared over quantity ampere times second cubed, is used to measure electrical potential difference. To convert from joules to calories, which are a non-SI unit of energy, so calories is not metric, but we convert from joules to calories all the time, just like you could convert from meters to feet. Use the conversion factor, 1 calorie equals 4.186 joules. No, you do not need to memorize this, but you do need to use it, and we're going to do some examples together. Metric base units combine to form metric derived units. So what's the example for density? Grams per centimeters cubed, or grams per liter. What's the unit for force? Newtons. What's the unit for volume? Centimeters cubed or liters. All right, so we're going to go into the problem set and work on some of the problems. And there are some more websites here. If you do go to any of them and you're like, oh, Mrs. KJ, you should actually talk about this, send me an email, let me know. And all right, so let's go to our problems book. Actually, I'm going to go through what I have for notes so far. So review metric system. Most of the word uses the SI, which is based on the metric system. The metric system has 7 base units and many derived units, which are made from various combinations of base units. The metric system is based on powers of 10, so converting from one unit to another is simply a matter of multiplying or dividing by various conversion factors, or of course, moving the decimal to the left or the right, which is the same as multiplying or dividing by factors of 10. That's why we can do it. Derived units are used to solve problems in numerous chemistry topics. So, System International, make sure you know your 7 base units: meters, kilogram, Kelvin, second, mole, candela, ampere. Base units can be subdivided or multiplied by factors of 10, which is the same as moving the decimal to the left or the right. For example, if I have the number 10, and I take 10 times 10, you know that equals 100. All you did is move the decimal point one spot to the right. So moving the decimal to the right or the left is the same as multiplying or dividing by 10 or 100 or 1,000. Make sure you know prefixes kilo, centi, milli, micro, and nano are important to know, but we're not going to talk a lot about them now. Temperature is measured in kelvins, and absolute zero, 0 Kelvin, is the temperature at which all molecular motion stops. Okay, close your eyes. What does liters measure? Volume. And how is liters abbreviated? Capital L. What does grams per centimeter cube measure? Density. What does newtons measure? Force. What do pascals measure? Pressure. What do joules measure? Energy. And what is the abbreviation for joules? Capital J. What do volts measure? Electrical potential difference, or voltage. And to convert from joules to calories, so remember calories are not SI units, but it is the unit for energy. We use the conversion factor, 1 calorie equals 4.186 joules. Again, they will give this to you on the quizzes. You just need to know how to manipulate it through algebra, which we're going to talk about in this section. Problem set 7, metric system, base unit. Objective, distinguish between metric base units and derived units. Metric units used to express measured quantities may be either base units or derived units, and their magnitudes or sizes are indicated by standard prefixes. There are 7 SI base units. All other metric units are derived from these 7 units. All but one of the 7 SI base units are defined based on stable properties of the universe, such as the speed of light. Only the unit for mass is defined by an actual physical object. For convenience and clarity, scientists use standard prefixes to indicate larger or smaller units. Each prefix indicates a specific power of 10. So for example, kilo is 1,000, hecto is 100, deca is 10. So all the prefixes are a specific power of 10. All right, let's look at the remember first. Units. Units raised to powers are indicated by superscript. For example, centimeters cubed for cubic centimeters. So superscript means up above. Like Superman flies up above. Versus a subscript, which is down below, like when we write the chemical formula H2O, how the little 2 is smaller and down a little bit. So that's a subscript. Exponents are called superscripts. Units with negative exponents appear in the denominator when the units are written as fractions. For example, meters times seconds to the -1 power is the same as meters per second. Okay, so hopefully you remember this from math class. If not, that's okay. If you have a unit to a negative exponent, that means it belongs on the bottom of a fraction. The 7 SI base units are the meter, kilogram, Kelvin, second, mole, candela, and ampere. All other SI units are derived from these 7 base units. Identify metric base units. A student measured the length, mass, and temperature of an object. She also measured the amount of electric current flowing through the object over time. Which of these sets of measurements could be the student's measurements? Okay, so let's take them one at a time. First of all, she measured length. What is the unit for length? Meters. How is it abbreviated? M. All right, so let's look. Does A have a lowercase m? Yep, it does. Okay, so A is a possible answer. Let's look at B. Yep, we have a lowercase m for meters, so that's a possible answer. Look at C. There are no meters, so C cannot be the answer. And look at D. There are meters, so it's a possible answer. All right, let's go to the next one. Mass. What is the unit for mass? Kilograms. What is the abbreviation for kilograms? kg. All right, so let's look at the first one. K, but not kg, so that's Kelvin. That's temperature. Okay, no kg, so our answer is not A. Oh, there's kg, so it could be B. Let's go down to D. Oh, and D can't be the answer. We already said C can't be the answer, so let's double check the rest. Temperature, Kelvin, electric current, amperes, and time, seconds. All right, so our answer is B. So when you get a long problem like this, just break it down and try and cross off answers one at a time instead of checking every single one and every single one. Maybe you'll find that way easier and faster. If not, that's okay. The prefixes used with SI units indicate powers of 10. For example, the prefix kilo, indicated by the letter K, indicates 1,000, which is the same as saying 10 to the third units. So 1 kilometer is 1,000 meters. So instead of saying 1 kilometer, we could say 1,000 meters. Convert between metric base units. All right, let's read the tip first. When you perform unit conversions, always check to make sure your answer is reasonable. For example, if you are converting from a larger unit to a smaller unit, such as from kilometers to meters, your answer should be larger than the number you started with. Okay, so you know that 1 kilometer is 1,000 meters. So if you start out with 100 kilometers, you better make sure you have more than 100 meters, otherwise you did it backwards. All right, before I go through and explain the math problem that they want us to do, which involves a lot of manipulating of units, we're going to start out with one that hopefully should make sense to you off the top of your head, because we're going to be learning a pattern that we're going to use for the rest of the year to do math problems. The pattern takes practice. I promise you, once you get it, you'll be like, oh yeah, no problem. But that being said, it can take a couple weeks to get it. So please don't give up. Please let me know how I can help. It takes practice. All right. So let's go ahead and let's look at our first one. Our first one says, how many apples are in 5 dozen? Okay, in order to answer that, you need to know that 12 equals 1 dozen, which hopefully you know. So if I have 5 dozen, do you know what the answer is? Well, let's see. We started out with 5 dozen, and some of you know the answer off the top of your head, which is good. And the reason that I'm picking something you're familiar with is so that you can see the pattern or the process more easily. So, all right, so I did just change something, sorry. I changed it to 2 dozen, because hopefully that one you can do off the top of your head. 2 dozen would be how many apples? 24. Okay, so let's look at how you did that mathematically. We started out with 2 dozen. Now when you do math problems, you always start out with the amount that you're given. Okay, and then what we're going to do is we're going to make it a fraction. We're just going to put it over 1. Just like in math class, what does 5 over 1 equal? It equals 5. Okay, what does